Okay, this video is a continuation of what we've talked about so far with geometric series, but now we're going to bring the symbol sigma in. Remember, sigma is just another way that they can say add all these up or find the sum. Okay, so I put on the top right here the three geometric formulas that we need to know for sequence, for finite geometric series, and for infinite geometric series. Okay, remember, as I've been saying, it's a good idea to have those notes right next to you to make things a little bit easier and give you something to reference off of. Okay, so the first thing they want us to do here, I know that this is saying to find the sum of these first 7 terms from 1 to 7, and I know this is geometric because of the equation that they give me here. All right, so I know if I compare that to the equation that we get for a geometric series, I can see how that is pretty straightforward here. All right, so they want me to find the sum, all right, or a geometric series. I know this is going to be finite. Why do I know it's finite? Because it goes from terms 1 to 7, which allow me to figure out how many terms there are. In order to figure out a geometric series that is finite, I need the following information. I need a sub 1. Well, I know that a sub 1 in this case is 2 because that's what's in that position in the formula. Okay? I need to know r. I know that r is 3 because, again, that's what's being raised to a power. And then I need to know n, how many terms there are. And if you remember, the way that I said to do this with sigma is go top minus bottom plus 1. And that tells me that there's 7 terms here. Once I have these 3 pieces of information, I can then find the sum of the series. So I'm going to use the finite series, which says S sub n is equal to a sub 1 times 1 minus r to the n over 1 minus r. And this will simplify to 2 times, let me grab my calculator here, 1 minus 3 to the 7th, which is negative 2186. And we're going to divide that by negative 2. Now the 2's are going to cancel and the negatives are going to cancel. So I know very simply, I shouldn't have written S sub n there. I should have wrote S sub 7. The sum of these 7 terms is 2186. All right. Now let's try this one. Okay. Again, I know this is a finite geometric series. If it's a finite series, the first thing I want to do is identify a sub 1. Now, if you notice, from the formula, look at the formula again. A sub 1 times r to the n minus 1. If you notice, there's no number in front of this negative 4. So I'm going to say that a sub 1 is 1. All right? I know that r is negative 4 because that's what's being raised to the power. And then if I take 9 minus 1 plus 1, I know that n will be 9 terms. All right? So S sub 9 is equal to a sub 1 times 1 minus r to the nth divided by 1 minus r. All right, so let's see what we get here. I have 1 times, we'll grab a calculator, 1 minus 4, but negative 4 raised to the 9th. Let's see how that works. I think it's 262, 145. Divided by 5. Now, I want to double check myself here. I know that if I take negative 4 and I raise that to the 9th, I get that, and then 1 minus that would give me 262, 145. So it worked. what I did on the calculator worked. All right. So let's see. I've got to take 262, 145 divided by 5, and that tells me the sum is 52,429. 52,000. What was it? 429. Okay. Now, what if they give me this geometric series, all right, with sigma in there, but they're asking me to find the number of terms that there are, all right? Well, first of all, I know it's going to be finite, okay? And I know it's going to be finite because, why do you think? Well, the reason why it's going to be finite is because I know that R value is greater than 1. If this was infinite, it wouldn't have a sum if the R value is greater than or equal to 1. All right, so in order to do this, let's see here. We know the following facts to be true. We know that S sub n is negative 27,993. All right, we know that A sub 1 is negative 3. We know that R is 6. All right, and what they want us to find is n. All right, so I'm going to go to my formula here. I have negative 27,993 is equal to A sub 1, negative 3, times 1 minus R to the nth over 1 minus R. All right, so I have to solve this equation for n. Let's see here. I'm going to take negative 27,993 is equal to negative 3 times 1 minus 6 to the nth over negative 5. Okay, so now I'm going to start kind of playing with my calculator here. I'm going to take negative 27,993 and I'm going to multiply it by negative 5. That got rid of that negative 5. Now I'm going to divide it by negative 3. That got rid of the negative 3. So I've got negative 46 655 is equal to 1 minus 6 to the nth. Okay. So now what I'm going to do is I'm going to take this number, subtract 1, and that gives me negative 466.56 is equal to negative 6 to the nth power. All right. I need to figure out 46,656 is going to be 6 to what power? I'm going to guess 6 to the 5th. Nope, too small. How about 6 to the 8th? Too big. How about 6 to the 7th? Nope. How about 6 to the 6th? There we go. So this is really 6 to the 6th is equal to 6 to the nth. Notice I dropped the negatives off because both sides were negative, which tells me there are 6 terms in this sequence. So these kind of problems, guys, take a little bit of playing around with the equation. All right, but they're very doable. All right, let's take a look at another one here. Again, they want me to find n. I know that S sub n is equal to 61. I know this is finite because that R value of negative 3, its absolute value is greater than or equal to 1. So let's see. I know A sub 1 here is 1. Notice again, there's no number in front of the R value. I know that the R value here is negative 3. Okay. So I'm going to take the equation. I have 61 is equal to A sub 1 times 1 minus R to the nth divided by 1 minus R. Let me clean this up a little bit. I have 61 is equal to 1 times 1 minus negative 3 to the nth over 4. All right. So let's see what I have from here now. I have 61. I'm going to multiply by 4 to get rid of that divided by 4. I'm going to divide by 1, which doesn't change it. So that would be 244 is equal to 1 minus negative 3 to the nth. I'm going to subtract 1. Whoop, so that would give me 243. I'm going to divide by negative 1 to get rid of that negative symbol in front there. Let me move this work up here. So I have negative 243 is equal to negative 3 to the nth. All right, I'm going to drop the negatives. So I know that 243 is equal to 3 to the nth. And then I got to figure out 3 to what power is 243. I'm going to guess 5. Yes. So I know that 243 is 3 to the 5th. Because the bases are the same, drop them. I know that there are 5 terms in this series. Okay? We can also do convergence and divergence. Now, convergence and divergence is pretty simple as long as you're able to identify R. In this case, I know that R is 4. The absolute value of 4 is greater than 1, greater than or equal to 1. So that tells me this diverges. And when it diverges, I can't find the sum. All right? If I look at this one over here, notice again, I kind of jumped ahead, but notice the top number there. Do you see that infinity symbol up on the top? That's telling me that we're dealing with an infinite series. Okay? So in this one, though, I'm going to simply look for the R value. The R value here is 4/5. And because the R value, the absolute value of the R value is less than or equal to 1, is less than 1, I know that this converges. Which means I can find its sum. And we're not asked to do that here, so I don't need to worry about it. All right? Okay, so we've got an infinite series here. I know it's infinite because on sigma, it goes from 1 to infinity. All right? In order to find the sum of a series, there are 2 pieces of information I need to know. A sub 1. A sub 1 in this case is 5. All right? Remember the formula for geometric sequence. I need to know R. R here is 1/3. All right? Pretty simple. So to find this sum, I'm going to take A sub 1 divided by 1 minus R, which would be 5 over 1 divided by 2 over 3, which would give me 15 over 2. I'm done. The sum is 15 over 2, or 7.5. All right? Let's try one more here, see how this works. I know it's an infinite series. When it's infinite, the first thing I need to do is figure out what the first term is. The first term here is going to be 1. All right? The R value here is 4. Now, if the absolute of the R value is greater than or equal to 1, this diverges, which means I can't find its sum. So I would simply say that it diverges. All right? Notice in the previous one, R was 1/3. In this one, R is 4. We can't find its sum. Its sum does not exist. Hopefully this helps. Let me know if you guys have any questions.